Okay, so we're going to start here. And we're just going to kind of go over real quick our nephron anatomy. So we have the Bowman's capsule, and then we have our proximal convoluted tubule, our descending limb, and our ascending limb of the loop of Henle, right? Because this is the loop of Henle. And then we have our distal convoluted tubule and our collecting duct. You can also see here that we have the vasa recta, okay? And the vasa recta moves opposite of the filtrate that is moving through the loop of Henle. That'll become important later. We'll talk about that. Don't worry about it. The glomerulus is just the network of capillaries in the kidney but this is specifically the site of filtration. Again, we'll kind of talk about that later. And then the Bowman's capsule just surrounds the glomerulus. All right. So, again, here you see we have our proximal tubule, our loop of Henle, our distal tubule, and our collecting duct. And then we have our cortex and our medulla. All right, so this is where it gets a little bit confusing, and I think that the problem is that everybody likes to start with the proximal tubule because that makes sense. That's where it's coming in from. Really, I'm going to start with the distal tubule because that's what's really changing things and affecting things. So maybe it'll make a little bit more sense. So, but we know that the fluid is coming up through our ascending limb, right? So these walls are impermeable to water, but they allow sodium to get out. So when the sodium goes out, it increases the osmolarity of the medulla. Okay? So we're going to just show the sodium going out this way. Okay? I'll go ahead and give you blue for our little sodium molecules. Boom. Okay. Now, we know that when we increase osmolarity or we increase tonicity, what happens? Water follows solutes, right? So then that's where you're going to see the fluid that's starting through the proximal tubule. It's going to start releasing water. And I really shouldn't have done blue for sodium, but that's okay. Okay. So the descending loop is going to start releasing water because the water is following the solutes that were released from the ascending loop, right? So, and then this is hypertonic, right? And Dr. Schaefer told us he didn't care about the numbers. He just cares that we understand the process of it. So this is hypertonic. Down here, it is really saturated, okay? But it also reaches a point where it's isoosmotic between the loop of Henle and the medulla. Okay, so at this point, no more fluid is leaving the loop of Henle. Okay. And then we go up our ascending loop. And again, remember, what did I say about these walls? These walls are impermeable to water. But it's gonna pump out all that extra sodium that was collected or that was concentrated through the process that happened over here. So now we have really, really concentrated filtrate right here, but we don't want it to be that way. And so what happens is it pushes the sodium out. And again, that's how you see this kind of circular relationship that happens, right? So then once it's leaving the medulla and back into the cortex, now it's going to be hypotonic. The fluid that is inside of the distal tubule is hypotonic compared to the cortex. Okay. So, however, on our distal tubule, it doesn't just accept water or give up water based on gradients. The distal tubule is influenced by hormones, specifically ADH. Okay. The other name that this can be called is vasopressin.
Mommy?
Hold on. And it can also be called arginine vasopressin or AVP. Okay, so we were talking about vasopressin, AVP, ADH. Those are all basically the names for the same thing, right? So ADH acts on the distal tubule and our collecting duct. Okay, this is our collecting duct. Sorry, I didn't have it written in there before. Okay, so ADH specifically acts on our distal tubule and our collecting duct. Now, when ADH is present, what are the situations that are occurring in the body? Okay, so we have dehydration, right? Or we might have low blood pressure. Those are two very common things that would trigger ADH to be released. So then when ADH is released, that makes these walls permeable to water. And so then the water that is in this tube goes out to the cortex because since it's hypotonic to the cortex, water is going to follow solutes, right? So then once the ADH acts on the distal tubule and the collecting duct, it's going to open up those pathways for water to go through, and then water will act on the laws of osmosis at that point. And so water will leave the distal tubule, or it'll leave the collecting duct. And at that point, you'll get more concentrated urine because the body is trying to reserve that water.